Hi everyone, thank you for joining. In this video we're going to solve an interesting integer equation. We're given that a and b are integers and a to the 5 minus b squared is equal to 4, and we want to find the values of a and b such that it solves this equality. If you like to pause the video and try it yourself first, then we could go over it together. Right, one thing to observe, that a cannot be 0 and b cannot be 0. If a is 0, we have 0 minus b squared, which is equal to 4, and that's impossible because b is a real number. And similarly, if b is 0, we have a to the 5 is equal to 4, but a is an integer, so no integer to the power of 5 will give us 4. So a or b cannot be 0. Now we have a to the 5, and if we square that, that's going to give us a to the 10, right? And that will equal to 1 in mod 11. Okay, so I've used here Fermat's little theorem. If you're not familiar with Fermat's little theorem, it states that if a is a natural number and p is a prime such that p doesn't divide a, we will have a to the p minus 1 is equal to 1 in mod p, right? So p is 11 in this case and p minus 1 is 10 as in the example. And is a natural number? Well, a to the 5 may not be a natural number because a might be a negative. We said a is an integer. So, but when we square that, we're definitely going to get a natural number. So we can apply Fermat's little theorem. So a to the 10 is equal to 1 in mod 11. However, a could be a product of 11 itself. So therefore, we must have that a to the 10 is equal to either 0 or 1 in mod 11. 0 if a is a product of 11, 1 by Fermat's little theorem, right? But because we squared a to the 5, that means we should also add minus 1, 0, 1. So minus 1 is another possibility, right? So we have a to the 10 is equal to either minus 1 or 0 or 1 in mod 11. Now going back to the original equation, we have a to the 5 minus b squared is equal to 4. That implies a to the 5 minus 4 is equal to b squared. But we know that a to the 5 is equal to either minus 1, 0 or 1 in mod 11. That means a to the 5 minus 4 will equal to minus 1 minus 4, which is minus 5, 0 minus 4 is minus 4, and 1 minus 4 is minus 3 in mod 11. That will equal to 6, 7, or 8 in mod 11, right? So in other words, a to the power of 5 minus 4 can either be 6 or 7 or 8 in mod 11. But we also have that a to the 5 minus 4 is equal to b squared, where b is an integer, non-zero integer. So now the question that we need to answer is, what is an integer square in mod 11? So if we quickly have a look at the possibilities, 1 squared is just 1 in mod 11, 2 squared is 2, 3 squared is 9, 4 squared is 16, which gives us 5 in mod 11, 5 squared is 25, which is equal to 3 in mod 11, 6 squared is 36, which is 3 in mod 11, 7 squared is 49, so that's 5, 8 squared is 64, so that's equal to 9, 9 squared is 81, so that's equal to 4, and 10 squared is 100, which is equal to 1 in mod 11, right? And if you notice that we get 1, 2, 3, 4, 5, and 9, right? Because if you continue with 11 squared, 12 squared, 13 squared, and so on, we will get the same answers. That means an integer square in mod 11, so that means b squared must belong to a set 1, 3, 4, 5, 9. And of course, b could be a multiple of 11, so I'm going to add 0 as well. So these are the only possible values, but we are given that b squared is equal to a to the 5 minus 4, and that belongs to the set, as we worked out here, 6, 7, or 8 in mod 11. In other words, if we compare these two sets, we will see that there is a contradiction So in short, there is no solution to this equation. Okay, well, I hope you found it interesting and challenging. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.